Which of the provided moment diagrams best represents the loading conditions upon the provided beam? We can see the beam in question over here. It's a cantilevered beam attached to one side of the wall and has a moment applied at the other side, as well as a distributed load in this section between B and A. So if you're like me and shear and moment diagrams are not your strong point, the first thing to do is go to the reference manual to find some examples. I'm not sure if there are any keywords that will lead you to this section first, so it will be helpful to remember that the reference manual does contain a section showing shear and moment deflections of various kinds of beams under various types of loading conditions. So go there first. Now let's look at the problem. We can see that the moment applied to the free end of the cantilevered beam is providing a constant amount of bending until an additional force acts on it starting at section B. This section is also the same for all answers, which means we can focus on what's happening in the other two sections instead. The middle section from B to A looks similar to example 19 in the manual on page 244. We can also see that the distributed load is causing the magnitude of the resulting moment to increase non-linearly over the distance from B to A. So that would eliminate D from the list of possible answers. Finally, there is a section from A to the point where the beam is connected to the wall. The first section closest to the anchor point looks like examples 21 and 22 in the manual, in the sense that there is no additional force applied to that section, but the moment is still being impacted linearly from the distributed load in the section next to it. This will instantly narrow down our answer to C. A and D show no additional influence on the moment, and B shows the moment slowly tapering off to the point that there's no additional increase in it. So again, the point of this problem was just to show you a way to use the process of elimination and some hints from the manual to get your answer, even if statics or structures is not your specialty.